Demand curves illustrate the relationship between some aspect of a consumer's economic circumstances and the quantity demanded of a particular good. In graph 9.1, we illustrated the relationship between income and the quantity demanded of a good. In graph 9.2, we illustrated the own price demand curve, in other words, the relationship between a good's price and the quantity that's demanded of that good. The final economic relationship that demand curves can illustrate is the relationship between the quantity demanded of a good and the price of another good. This is called a cross-price demand curve. We'll illustrate an example of it here. We begin with an initial blue budget constraint, a constraint that's formed by the person's income, the price of good 1, and the price of good 2. Our focus here will be on the relationship between the price of good 2 and the quantity demanded of good x1. As always, we'll indicate the initial optimal bundle as bundle A. Next, we'll consider a decrease in the price of good 2. Such a decrease will cause a rotation outward of the original budget constraint to create the new magenta budget constraint. Bundle C then indicates the new optimal consumption bundle for the consumer. The move from A to C is the actual change in behavior the consumer will be observed to make when faced with this price change. To isolate the substitution effect, we take the final budget constraint, move it in parallel until it is tangent to the original indifference curve to come up with the compensated budget and the optimal bundle B on that compensated budget. Notice that we've drawn bundle B exactly under bundle C, which implies that the good we're dealing with here on the horizontal axis is quasi-linear. As income changes from the magenta to the green budget constraint without a change in opportunity costs, the consumer is not changing her consumption of x1 at all. Thus, x1 is neither a normal nor an inferior good. It's borderline between the two, or what we've called a quasi-linear good. We'll then use the same trick we used in the previous graphs, except now we'll put the price of good 2 on the vertical axis, leaving again the horizontal axis as simply x1. Point A on the upper graph then drops down to the lower graph and settles at the height of the price of good 2 that originally existed, in other words, the high price for good 2 before it fell. Bundle C, on the other hand, happens on the magenta budget, the budget created by the lower price for good 2. Thus, when point C drops down to the lower panel, it drops all the way down to the price for good 2 after the price dropped. Bundle B lies on the green compensated budget, which has the same slope as the magenta budget, and therefore the same price for good 2. Thus, when we drop point B down to the lower graph, it also happens at the lower price P2 prime. And since we've assumed that x1 is a quasi-linear good, it happens at the same quantity as bundle C. In the lower graph, point B and C therefore become the same point. What matters for the cross-price demand curve are bundles A and C, because those are the bundles that the consumer actually chooses before and after the price change. We therefore draw a line connecting A and C to estimate the cross-price demand curve. In this case, of course, point B happens to be the same point as point C because of our assumption of quasi-linear tastes. But it's through point C that we're drawing the cross-price demand curve. Quasi-linear goods are borderline goods between normal and inferior goods. If, in this example, x1 had been an inferior good, then point C would have been to the left of point B, implying a shallower cross-price demand curve. If, on the other hand, x1 had been a normal good, then point C would have been to the right of B, creating a steeper cross-price demand curve. In fact, if x1 is a normal good, point C could lie all the way to the right of point A, in which case the cross-price demand curve would in fact be downward sloping.